Okay, folks, for today's lesson, we're going to be learning about Lewis dot diagrams. A Lewis dot diagram is just a representation of the valence electron structure of the atom. So, we're going to kind of be dealing with electron structure again. Today, though, we're only going to be caring about the valence electrons, and I'll show you more about what I mean by that. So, let's just jump in and do an example. Here we've got the hydrogen 1 atom, and we've got the Bohr model of it here. We can see it's got one proton, there's no neutrons in there, and there's one electron on the outside. And so the first question we have to ask ourselves is how many valence electrons are there? Well, there's only one orbital, and so that means that since that one orbital has one electron, that it has one valence electron. Okay, but we could also get this information without the Bohr model. So one thing you could do for all these problems is draw yourself a Bohr model of the atom that you're looking at. You don't really need to, though. A much easier way is just to look at the periodic table. Look at the row that your element is in. So hydrogen is in this row right here. And you'll count how many elements over it is. So since hydrogen is the first element in that row, it's only going to have one valence electron. Right? And we'll kind of compare that with helium in an example in a second here. Okay, and so then we're just going to write that symbol down. So again, we had hydrogen, that was our element. So that chemical symbol was H. So we write down the chemical symbol for the Lewis dot diagram. And then we just draw the number of valence electrons on the side. And so I always start on the right side here. It really doesn't matter where you start, though. You could start anywhere. And you just draw that one electron there. Okay, so then let's contrast that with helium, because that's going to be our next example. So here we've got a helium-4 atom, and again, I drew out the model here, so 1, 2 protons, 1, 2 neutrons, 1, 2 electrons. And again, since there's only one orbital, the number of valence electrons is also going to be 2. But we can get that, again, from the periodic table of elements. So if we look at this row, there's 1, 2 elements in this row, which means that there's 2 valence electrons. So then for our Lewis dot diagram, we're just going to write down the chemical symbol. Again, that's He. So then we'll write down He. And then we're just going to draw those 2 electrons on there. Now, since the first orbital only holds 2 electrons, we're just going to draw them right next to each other. 1, 2. This is going to be a little bit different in the examples coming up. But to begin with, you can just draw your electrons right next to each other for helium. In our next example, we're going to take a look at lithium. So again, I've got the Bohr model right here. So 1, 2, 3 protons, 1, 2, 3 neutrons, 1, 2, 3 electrons. Okay, and so then we can take a look at lithium. And we can see that lithium is the first element in its row. Right? It's the first one in here. So that means it's only going to have one valence electron. Right? We can also see that when we draw the Bohr model, we only put one electron on the outside there. Okay, and so then the Lewis dot diagram for lithium is going to look a lot like hydrogen. We start with the chemical symbol for lithium, Li. And again, we're getting that from the periodic table. So if you look at lithium on the periodic table, it's Li. So we start with Li, and then we just add the one valence electron. Easy enough. Okay, let's do a little bit more complicated example next. Next up, we have carbon-12. And so we've got the Bohr model here, 1, 2, 3, 4, 5, 6 protons, 1, 2, 3, 4, 5, 6 neutrons, 1, 2, 3, 4, 5, 6 electrons. Okay, and then our next question is how many valence electrons? So we find carbon on the periodic table. We start over here and we count how many over for carbon. So that's 1, 2, 3, 4. That means that carbon has 4 valence electrons. Now again, you can also get this from the picture of the Bohr model. 1, 2, 3, 4 in that outer orbital. But it's a lot easier just to look at the periodic table and count how many over it is in that row to figure out how many valence electrons it is than it is to try and figure it out based off the picture because you have to draw the whole picture. And so this is a nice way to skip having to draw the picture. But I'm just putting that up there just so we can see where that number's coming from. Okay, so then we write down the chemical symbol for carbon. Now we're going to fill in electrons. Now, since we're in the second row, we're in the second orbital, what we need to do as we fill in these electrons is fill them in one at a time as we go around carbon. So 1, 2, 3, 4, right? If you think of it, there's like 4 sides to this figure, and each side needs to get 1 electron before any sides get 2. And that's because electrons tend to form these pairs, but they only start to pair up after all the orbitals, or after all the suborbitals are filled. And so there's going to be 4 of those little suborbitals where you can fill in electrons. Okay, so let's do one more example where we're going to end up with more than 4 valence electrons. And for that one, we're going to take a look at oxygen. So again, we can count in here 1, 2, 3, 4, 5, 6, 7, 8 protons, 1, 2, 3, 4, 5, 6, 7, 8 neutrons, 1, 2, 3, 4, 5, 6, 7, 8 electrons. So you could draw the picture of the Bohr model and see that there would be 6 valence electrons on the outside. But an easier way is just to look at the periodic table, find oxygen, a little bit to the right of carbon, and then we're going to count how many over that is. So 1, 2, 3, 4, 5, 6. So that means that oxygen has 6 valence electrons. For the Lewis dot diagram, we're just going to start with an oxygen in the middle here, and then we're going to start to fill in electrons around the outside. And so again, just like we did with carbon, each side gets 1 electron before any sides get 2. So 1, 2, 3, 4. Now we can start giving sides 2, 5, 6. Okay? Okay, so then let's just go through the first 2 examples on your practice problems together. And so our first example is beryllium. So if we look here, we've got beryllium right here. That's the second one in its row, 1, 2. So we're going to start by writing down the chemical symbol for beryllium, Be, and then we're going to give it 1, 2 electrons. And remember that we start filling in around the outside. So each side gets 1 electron before any side gets 2. So 1, 2. Okay. Next up, we're going to do sodium. Sodium is right here. That's the first one in its row. So we're going to write down Na, and then we're going to give it 1 electron, like that. And then that should be it. So go ahead and try and work through the rest of these examples. You're just going to write down the chemical symbol and start filling in the electrons. Remember to work around the outside, so each side gets 1 electron before any side gets 2. Let me know if you have any questions. Thanks.